Hello everybody and welcome to this last session on the Orange track. This time I'll try to briefly talk about how we can build intelligent apps or bring intelligence into our applications using Azure Cognitive Services, which is actually something very easy to use. My name is Dan and I am a software developer which right now has a more business-oriented role. I'm a business development manager, but I still write a lot of code. So that's why this session is mostly about how we can make our apps more intelligent. And this means that we will also look into some code to see how we can actually interact with Azure Cognitive Services. So let's get right into it because there are a lot of things to cover during this talk and I just want to keep it in 1 hour. But before we go further, just I want to say a huge thank you to our partners that made this conference possible. Even in this hybrid format, it's still important that we can gather together and talk about cloud topics that could actually help us all bring some innovation into our day-to-day business activities. Now, talking about the current state of applications and about this whole concept of intelligence, of artificial intelligence or machine learning, it's not necessarily something new because I think it's around 4 or 5 years that we started to talk about bringing intelligence into different type of applications. So the topic itself is not new, but the hype around this machine learning topics or AI topics is increasingly growing also today or nowadays. And especially in these very special times that we witness, the whole thing of bringing intelligence into application becomes more and more stringent. And technology leaders around the world say a lot of times how important actually intelligence is, how important data is, how important devices are. And here is a very brief quote of Satya Nadella, which is from 2018 actually, so it's not really recent, but you can see here that the ideas that he actually brings to the table are today very popular, and we can see these things happening basically in our households and with all devices or mostly all appliances that we interact with. The whole idea is actually that digital technology is very important and it becomes a major part of our lives. It is in all devices, in a lot of different applications, in a lot of different appliances that we use day by day in our households or at work and so on. And that's basically why Satya says that the whole world is actually becoming a computer. And artificial intelligence is actually the runtime which is going to shape what we do right now and what we do going forward. And usually when business leaders or technology leaders make such statements, all the other businesses in different sectors, they soon follow and try to go that wave, to ride that wave. And this happened, of course, in the entire world, and this has led to the fact that nowadays we see basically that everything is advertised as having something to do with the AI. For instance, I stumbled upon an ad of an iron, and they said that it's built that it has built-in AI. Now, of course, it's a little bit strange, and if we think, okay, but why do we really need artificial intelligence in an iron? And it sounds just like a little bit funny, but just that we get an idea about how important this topic is that most manufacturers of all kinds of products start to advertise their products as being driven by artificial intelligence in a certain way. And it could even become funnier. I've seen also an ad of an AI-infused umbrella, which is, again, very interesting because, okay, we need a smart umbrella, or we could see why we need a smart umbrella, but having really artificial intelligence in it, well, maybe this is not really that straightforward. And more than that, we have nowadays refrigerators that run on AI. So basically, we have this type of conception that artificial intelligence is actually anywhere. And just to be also a little bit funny, all applications or business owners, they try to do something with AI. And they try to advertise their products as having something to do with artificial intelligence or machine learning. And this leads to very, very strange things that I have seen and witnessed. Like, for instance, we use machine learning algorithms to greet the user with a personalized message. And what it actually does when you look in the code, it just takes a name from somewhere and it prints it somewhere. Of course, this is a very simplified example, but we saw this type of ads or of statements about using machine learning, but in the end, what you actually use is not always real artificial intelligence, or it is not always real machine learning. And this brings basically in discussion another very important topic, and this one would be, okay, do I really need machine learning in what I want to do, or do I really need artificial intelligence in what I want to perform? Because often we see that we are in this type of situations where we have a very simple problem, but we say we need to implement or we need deep learning or machine learning. And as you can see from this picture, well, depending on the problem that you have, machine learning or artificial intelligence is not always the answer. So a very first important thing is to, understand that it's important that this concept of bringing intelligence into the applications or products that we create is important. But there are some things that you can solve easier. So you don't really need machine learning or artificial intelligence for certain type of tasks. And this brings me to the next topic, or to the next idea is, but what would be some use cases, some scenarios where we could use some machine learning or artificial intelligence in our applications without trying to use a very, very complex algorithm for a very, very simple problem. And here are some common use cases. And what I want to say is that these use cases are not only theoretical. So these use cases that you see here right now on the screen are use cases that we at Avelgo worked on during the last year. So each of these points that you see here is something that we have implemented, and something where we, and topics where we have used in one way or another, of course, machine learning or artificial intelligence. So if you have, for instance, an application like a forum where different people post different type of contents and you want to moderate this, of course, having a human doing it's not really helpful. So if you want to moderate content, automatically, using machine learning is a way to do that, or this could solve the problem that we have. A different type of use case or approach was simply analyzing the sentiments of certain texts, usually on social media like Facebook or Twitter or Instagram and so on. Because brands usually want to know what people say about them. And this is another very common use case that we have implemented at different customers, where we analyze the text and try to see if their brand name is associated to rather positive talking or negative or neutral. Then, for instance, you could use machine learning to identify, for instance, in a factory, faulty products. So you can have a camera that basically films products that are passing by on a production line, and using machine learning, you can identify which products are faulty and which products are okay. Then if you are in the video business and want to do something with video, you generate video content, you could use machine learning to automate different type of tasks like transcripts, translations even, and so on. If you have an e-shop or an e-commerce platform, you could use machine learning to create a recommendations engine. For instance, if the user goes on a certain product, then you can recommend basically similar products, not only on the history of the user, but on more complex data points. Then another very interesting thing where we used machine learning from Azure in a real project is actually an IVR. So there was a company that just wanted to create an IVR that could interact directly with customers. So customers would call a certain number, But then, well, a robot would respond, and the customer would have a regular conversation with that robot. Of course, the topic of the conversation was very, very simple and very, very clear. It only had to transmit some numbers, and the robot had to understand those numbers and then perform some type of actions based on it, and transfer that information to some other parts of the application. But the idea is that for this use case, the robot would need to understand the natural language, because the customer might formulate the numbers or the sentence in which it transmits the numbers in different ways. So the robot would need to be able to understand that and to extract the intent of this specific customer. And of course, one other very, very important topic, and I think it's a very real topic, a very important one, is if you want to digitize handwritten forms. And this could be very, very useful from the public sector to clinics and pharmacies and things like that. So these are all very common use cases that we have encountered during the last year, and on which we worked and implemented one way or another machine learning in order to solve this type of tasks. Now, you ask yourself probably, okay, I want to implement something similar, but how should I get started? And of course, if you ask a data scientist or an AI expert, they would say, okay, you would need to train a model, you would need to provide some very huge data sets for that. You would need to test that model, and then, of course, implement it or use that model or in your applications. And of course, this would consume a lot of time, a lot of resources, both financial and non-financial. So for smaller businesses or mid-sized businesses, this might not be a very good thing. But the good news is that in Azure, we have a lot of features that we can use in order to build artificial intelligence into our applications without the need to perform our own, let's say, AI processes, like training a model, providing data, cleaning up data, and so on. And all these services that Microsoft Azure provides are, let's say, grouped together in a certain name, which is Azure Cognitive Services. So Azure Cognitive Services are cloud-based services with REST APIs available to help developers build cognitive intelligence into their applications. What this actually means, it means that you as a developer of a certain application, the only thing that you would have to do is simply to make a call to a certain REST API with a certain type of information, and then that API would provide you with an appropriate answer that was generated by a machine learning algorithm. And these APIs, these services that we have in Azure Cognitive Services, we can group together in 5 different categories. We have the vision APIs, the speech, language, web search, and the decisions. Now, for the Vision API, we have several sub-services or sub-APIs that we could use. Maybe the most popular or the most commonly used is what we call computer vision. And this is a service where you just provide an image, either you upload it or you provide it, or you provide it via a new URL. And then the service returns you a lot of information about that image, like what you see, what object do you see in that image, what type of other information, if you have faces in that image, if you have brands in that image, and so on. Then we have also a custom vision service where you can train your own model very, very easily. You just have to provide pictures, and then the model will be trained directly by Microsoft Azure. We have a face service. This is a more advanced service for getting information about faces of people. And this is actually kind of very interesting because you can provide a picture where you have one person or a group of persons. And this API actually, using artificial intelligence, can tell you what is the mood for each of those persons, what age they are, and things like that. And you could use, for instance, this type of information very, very easily in marketing, for instance, or in ads, for instance. Based on this type of information that you can extract, you can maybe provide the user with a certain content that would be much or more appropriate for the user's mood and for the user's age and other things like that. And then we have some new service, which is the form recognizer, which is a service that you can just provide forms to it, and it would extract the information from that form in key value pairs. And then we have another service that is right now retiring, so it won't be here for longer because it's now part of the computer vision, which is the ink recognizer. And this service actually recognizes handwritten text. And then we have the video indexer service that provides you with different type of information that it can extract from a video stream. Going to the speech services contain also other sub-APIs. We have the speech service, the main service, which is there to add the speech-enabled features to your applications. And this actually means that you can simply have a robot talking to your customers. But the interesting thing about this speech service is that it's not just a regular robot. So it has a voice that mimics a normal user's voice with inflections and things like that. Of course, you can even customize the voice and other similar aspects. But of course, the main thing is that you can add conversation to your applications using these speech APIs that we have in Azure Cognitive Services. Another very important category of such cognitive services is language. And in language, we have several very, very important services that we have used throughout different projects. One of them is the language understanding, or LUIS, which allows applications to understand a person that speaks in their own words. So I say a sentence as the user, and then this API, this service, is able to extract my intent from what I have said. So if I say I need to contact HR, then probably this service would be able to extract as intent the fact that I want to contact HR. And it could tell, or it could transmit this information to other parts of the application that could then maybe, for instance, send an email to the HR department. Then we have another very important service, or nice service, which is the Q&A maker. Basically, you just provide a data set with information, and the Q&A maker is able to create questions and answers based on your data set. Then another very nice service is the text analytics service, which provides natural language processing, and this allows you, or this service basically allows you to extract sentiment from text, or extract key phrases, or even detect the language. For the web search, we have a lot of services that are search-related services and are powered by Bing. The list is huge, so I won't go through all of them, but if you want to build something like a more advanced search experience in your applications, you could do that using these services. And then last but not least, another very important category of such services that we have in Azure Cognitive Services are the decision services. And here we have, for instance, an anomaly detector, which basically monitors a data set and is able to identify abnormal behaviors in that data set. Then we have this content moderator service, which provides you with some tools that you can easily use in your applications to eliminate possible content that is offensive or it is simply not desired by your platform. Then we have a metrics advisor, which is a service that is able to look or monitor a very, very vast amount of data, of metrics that you provide, and is able to extract valuable information from those metrics. And then there is another service, which is the personalizer, and this allows you to choose the best experience to show to your users, learning from their real-time behavior. Now, of course, we don't have time in this session to go through all these services, but I just want to concentrate on a few of them that we used in different projects where we have implemented or where we have worked with these services for, as said, real applications. So applications that are online, that are working, that are fully production-ready apps. And the first one is the computer vision, which is which is actually a very, very nice tool and also very easy to use as a developer. The whole idea of it is that you just provide to the service an image, and the service is able to extract a lot of useful information that would be or that would allow you as developer to understand exactly what do you have in that specific pictures. And some features that we have in this computer vision service is that it returns a detailed list of tags that are related, of course, to the image content. It extracts or it creates a description of that image based on the tags that it creates. It is also allows you to identify faces. So if there are faces on the pictures that you provide, it just provides you with the coordinates where the faces are. It provides you also with some information about gender and age of that specific person. And if you want to get some more detailed information about the faces in a picture, you could use the Face API, which is actually a different service. But it also can tell you what image type it is. Is it a clip art? Is it a line drawing? Is it a normal JPG picture? And so on. And it's also able to extract information about the dominant color, scheme of the colors, black and white, and other things like that. And of course, it's able to tag your image or tell you if that image contains content that might not be appropriate for your use cases. And here we have some very basic examples. Here is, for instance, when we make a call to this API and we provide an image like we have here on the left side, and it returns you a list of tags that describe what actually the AI behind the service sees in this picture. And here we see things like grass, we say outdoor, house, sky, and we can see that the tags that we receive here are fairly accurate. So just using the tags, we already are able to identify exactly, okay, what type of picture this might be. Then, in a very similar way, we can also detect objects in the images that we provide to the service. And it happens similarly to tags. So you just upload the picture or provide a URL to a picture, and the AI behind this computer vision service returns you a list of objects that is able to identify in the specific picture. And here we see in this example that the AI sees, for instance, some different rectangles with objects that contain, for instance, kitchen appliances, a computer keyboard, and other things like that. Then the API is also able to detect if brands are present in some of the pictures or in the pictures that you want to analyze. And in this example, it clearly understands that, hey, we have a brand here, which is Microsoft. But we will have just a little bit later a short demo about it, and we will see that, okay, in this picture, it might be very straightforward that we have a brand. But I will show you a picture that where it is not that straightforward as we can see it here. But this computer vision API still recognizes a brand on that picture. As said, if we have pictures with persons or with people, the computer vision service is able to identify faces, and it provides you with information with the rectangle in pixels where those faces are located, together with some very basic information about that person, like the gender and age. And this could be, once again, very, very helpful. Another important thing here, or a very nice service that we could actually use in different applications, is simply that it could also generate thumbnails. So you just upload the picture to the computer vision service, or you provide a URL to it, and the service generates a thumbnail for it, which is a smaller version, which is friendlier to present, for instance, on smaller screens. So instead of the need to do this by yourself in your applications, if users upload pictures that you need to transform in thumbnails afterwards, you can simply use this service and it would do this for you. And then a very, very important part of this computer vision service is the optical character recognition service, or what we call, in short, OCR. And OCR is actually the process that detects content or detects text content in an image. And this service is very, very important. We used it in 2 different projects where we just wanted, for instance, to provide some pictures of some forms that were submitted by users and that were also handwritten, and we needed basically to digitize this information. So to get the information that we had on those written forms, to get them actually in a database. And of course, one way to do this would be to have a user that would take one form at a time and upload all the information that is needed to a certain database. But this would take a lot of times. The other way to do this is simply to make pictures of those forms, or if you have them in a PDF format, you can just provide them like that. And then the service is able to extract you the text that it sees. And then you can build easily an application that would extract the text and, for instance, save it in a database. And this service, this OCR service, has support for 25 languages, including Romanian. So if you want to do this for Romanian forms, you can do it. And of course, it is useful for digitizing written records. It could be from a public administration, from health clinics, from pharmacies, from different type of companies or institutions that actually work with users, let's say with clients, that have to submit or to fill in some forms. So you can actually do this or use this service to do this for you very, very easily. And then let's have a short demo about how this computer vision API works. And what I have here is, as I said, this demo is more developer oriented. I will have another demo which doesn't contain code. But for now, this is a very, very simple console application. And I provide the URL to 3 different images that are stored in a blob container on Azure. And then, based on those images, I want to perform, or I want to analyze them and to extract some information about those specific pictures. Now, even if computer vision is a REST API, so you would have to call some REST endpoints, and you can do that. But if you're using, for instance, .NET, but also for Java and also for Node, you have libraries. So you could use a library. In this case, for .NET, it is this Microsoft Azure Cognitive Service Vision Computer Vision library, and basically it wraps everything up, and it exposes some methods that you can simply use, and it makes the calls to the API behind the scenes. And here we have this method, which is this analyze image URL. We say here what type of information do we want to get for these pictures from the computer vision service, and then we get different types of information. For instance, we want to get the description. We want to get the tags. We want to get the categories. We want to get then, for instance, if we see objects on those pictures. We want to get information about if we see brands on those pictures. And then, we get some more information about faces, for instance, for color schemes and things like that. So if we run this application, by the way, the only thing that I had to provide here to this client library is actually this information, which is the subscription key for the computer vision resource that I have in Azure, and we have to provide the endpoint to which it has to make the calls. And everything else is done in this case by the SDK that we use. So if we run the application, it's just a very, very simple console application, nothing very, very fancy, but it will take each picture and it will give us some information about each of them. And here the first picture, we don't actually see them right now, but I will show you the pictures just to see that they are spot on, I would say. Here for the first picture, I also have a summary that it is a large body of water with a mountain in the background, and it has a very high confidence score. Confidence scores are always between 0 and 1. The closer this number is to 1, it means that it is more clear and sure that it is really that. And the closer the confidence is to 0, it means that the AI is not that sure that it really is what it says here, but it has a fairly good chance to be like that. And then we have here two categories that we have. And here we have, for instance, we have the main category outdoor, and here it says ocean beach. Well, it is not the ocean, we will see in that picture, but there's not really a clear way to understand if it is an ocean or not. But here we see that we have a water side as a category, and then we have tags. And the tags, you see that for each tag, there are different confidence scores. So for water, for instance, we could be actually 100% sure that this picture really contains a lot of water. But then, for instance, we have here hillside and distance with a lower confidence score, which means that, it could be that in the picture we really have a hillside and this concept of distance or island, but we are not really sure, or we can't be really sure about that. But on the other side, if you really want to use this type of information in your application, of course, depending also on your business domain and use cases, but I would say that everything that is above 0.7 is something that we can trust that it is fairly accurate. Then we see that the AI doesn't see brands in this picture, it doesn't see object, and it doesn't see faces, and we'll see that it really is the case for that. And then it extracts the color schemes for it. We don't have celebrities, and we don't have landmarks. Just to have an idea, this is the picture that we were talking about. So this was the picture that this computer vision service looked at, and it extracted those type of information from it. And as we can see, it's fairly accurate. So I guess that the AI had a very good understanding, I would say, about what really is in that picture. So if we go to the second picture, here we see that it is not able to provide a summary. We still have some categories. We see that the categories are not. We don't have a very high confidence here, but we have some tags here, and for tags we see that we have text, and text it actually it is with a very, very high confidence score, and then we see that we have a waste container with a very high confidence score and sky, and here. We see also some objects. It says that this is a parking meter with a certain confidence, and it sees brands in this case, logo of Pepsi, and we see that it is a fairly high confidence about the fact that it really sees brands here. Then we don't have faces. This picture is clearly not. It really doesn't contain content that is not appropriate, and neither it contains celebrities and landmarks. And if we look at the picture, this is actually the picture that we provided. I don't really see exactly where is that waste tray. I guess it's here somewhere. But it clearly identifies here, for instance, this logo of Pepsi. So if I just want to use this computer vision service to feed in pictures and get information about whether there are logos in that pictures, we can actually do that. And the third picture that we see here, we see also a description, and this is that in the picture it is a person posing for the camera, and it has a very, very high confidence about that. Then it has different tags like outdoor, human, person, mountain, hiking, clothing, which is actually very, very nice, because based on these tags, you will see that we can that it is very accurate to what we have on that specific pictures. And objects, it considers in this case the person as being an object. It doesn't see any brand, but since we have a person, of course it recognizes a face. And it then says that as a face that it is a male of age 34 at a certain location. And I'm very, very glad that the AI said I was 34, because I'm actually 36. So this was actually very, very nice by the service. Then, of course, if the content is for adults or racy, which is clearly not the case in this picture, and information about the color schemes and things like that. So you see, this is all the information that we extracted very, very easily about pictures simply by using this computer vision service from Azure Cognitive Services. So let's right now go one step further, and let's examine a different type of service, which is the language understanding service, which is actually kind of a very, very important one, because it applies custom machine learning intelligence to a user's conversation or natural language to predict the overall meaning. So just to get a certain idea about why this type of service is very, very important, is because the user actually could talk to this kind of AI or robot. And the AI or the robot behind it should be able to extract the intent of that specific user. Now, of course, when I'm talking or when I want to express some intent that I have, I might use a different language or different wording than a different user would do. And this language understanding service, or the AI behind it, should be able to understand the intent of the users, even if the language that they actually use or the wording that they use is actually different. So, and this is the main difference, or this is why we actually need artificial intelligence in this one, because it's not something having one word meaning a certain intent, but it's rather having somebody speaking and extracting an intent from that specific speech, which is kind of very, very important, and it has it really has, of course, different use cases. Now, this service, of course, is a little bit more complex, and we would have to also, let's say, make some custom training of this service. But the action that we use, or how do we use this service, is simply that the client application that we build, which could be anything that uses voice recording, we send this voice actually to this LUIS API, to this language understanding API, for instance, with the word or with the sentence that I want to call my HR rep. And then LUIS applies the learned model and tries to understand what actually this means, and it returns a JSON formatted response which contains a top intent. So what is actually the top intention of the user in that specific sentence? And then the client application receives that response, and based on that main intent that it receives, it could perform, of course, some different tasks. In this case, for instance, as also said earlier, it could simply send an email to the HR department, or it can start maybe a call with the HR department and connect the user to it, and things like that. So it's actually what the LUIS service does. It simply understands that speech and provides us with the top intent. And of course, that the application that we build, the service that we build, is then responsible to take that intent and then provide or take some further steps according to the use cases or according to the business needs. Now, as said, as this service is a little bit more complex, it could be that you actually need to also train it. And here, training this service is actually not very complicated. It's not like you would need a huge amount of data to do that, because LUIS makes it very, very easy. It provides even a web-based interface for you to do that, but you can do that also programmatically. And here, when training this LUIS algorithm, it's very important to understand that basically we have different domains of language. So, for instance, in the business domain, I would have intents maybe like some, I don't know, call a business partner, create a meeting, or call somebody else, or things that are related to the business. And then this is a specific domain. And then we can use LUIS, and in LUIS we can create different type of domains. By the way, there are some pre-built domains in LUIS, like business, HR, finance, IT, and similar. And in these pre-built domains, we can then create our own entities. Entities in this case mean that we can create our custom intents. For instance, here we have a certain intent, like book a flight, and then we can provide different type of sentences or wordings that would actually lead to that intent. And by the time we provide several type of several entities like that, the service would be able to learn actually also our custom intents that we actually want to use in our very specific applications. So this is actually how this language understanding service works. So we can fully customize it. Then another very nice service that we have in Azure Cognitive Services is text analytics. And text analytics actually provides us with advanced natural language processing over raw text. So here the main difference actually is that, when we compare this to LUIS extracts intent from speech. Now, in this text analytics service, it actually extracts information from text, and information like the sentiment. So I have a sentence. What is the overall sentiment of that specific sentence? Is it positive? Is it negative? Is it neutral? And things like that. But then if you provide a larger text to the service, it might be useful in your application maybe to generate something like an abstract. And in this case, you could probably use this key phrase extraction to simply extract some key phrases from a certain text that you provide to the service. Then it is able also to detect the language, and this could also be important because you could use this in basically all web apps that you create, where you want to make sure that user inputs are in a certain language. You can simply take the inputs, feed them to this text analytics service, and then, of course, extract the information about what type of language or what language this text or that text was written in. So there are really a lot of use cases for this text analytics API. And one of the use cases that we actually implemented also in a real project, what I will show you here is, of course, only a very, very, very small demo, but it was simply, having tweets from Twitter and looking to those tweets, extracting the sentiment of those tweets, and doing something based on those sentiments. But in that specific project, and also in this demo that I will do for you right now, what we want to do is perform all these tasks, without actually writing any line of code. So this is why we have here a mixture of other Azure services like Logic Apps and Azure Functions. And then, of course, we have on top of that, we have this text analytics service that is responsible to take a text from a tweet and return us with the sentiment of it. And for this, I will have to actually go to my Azure subscription, and here I have pre-built a resource group where I have different type of resources. And here, what I have, I should have here a logic app, which is this logic app. So actually, everything starts from a logic app. So I've created a very simple logic app. If I go here to see or to take a better look at this logic app, I see that it ran different times, and it actually was successful. Then if I go here to edit, I will go to the logic apps designer, and hopefully my internet connection works. And this logic apps has these very few steps. So first of all, we say that when a new tweet is posted, and we say that when a new tweet with the Azure hashtag is posted, and we check for this every 3 minutes. So when this happens, the next thing is detect the sentiment. So in this case, we actually connect to this text analytics service, and we provide the tweet text to this service. Now, this service actually returns us with a certain score, which is, of course, between 0 and 1. And based on the score, we can actually categorize it if it's positive, neutral, or not. And to do that, we actually have to do this in some way programmatically. So we have an Azure function here. So the result that we have from the sentiment detection, we feed into the Azure function that simply does this categorization. If it is between 0.1 and 0.3, it is red. If it is between 0.3 and 0.6, it is yellow, so neutral. And if it's above 0.6, then it means that it is positive. And then, as a last step in all this flow, we send an email. In this case, I connected to Office 365, and I send an email that contains, a subject in which I say that a new tweet was tweeted by somebody, and then it contains the body, and in the body, I simply say that, I want to display the content of the tweet, and then, of course, the evaluation that or the categorization in yellow, green, or red that was actually done by my Azure function. And this app is constantly running, actually, and this is the reason why I already have here a lot of emails. And these emails were actually sent by that logic app. And here we see that, for instance, we have this tweet, which was labeled as yellow. Then we have this tweet, which is once again labeled as yellow. And this one is again as yellow. I think most of them are yellow. This one is green. So in some way, this text analytics tool extracts the information from this tweet that it has a sentiment that is above 0.6. And that's why my Azure function categorizes it as green. And so on. So you basically see that this logic app is working. And once again, the cool thing about that is that I have created this type of flow without even writing any line of code. So I just connect to Twitter via a logic app. I get the text of one tweet. I send it to this text analysis service. This service returns us with a confidence score which is between 0.1 and 1. And then the only thing that I do is that I feed that information, that result, to an Azure function, and the Azure function does a categorization based on my business needs. So if it is, let's say, between 0.3 and 0.6, it is negative. If it is between 0.6 and or 0.7 or something like that, it is yellow. And if it is above 0.7, then it would be green. And then, of course, it really sends an email. So this is actually everything that I have done here in this type of flow. Once again, I have used this service, this text analytics service, which is based or which uses artificial intelligence behind, just to analyze some information without the need, in this case, to write any single line of code. And the main thing to notice, to note here is that you can easily integrate these Azure Cognitive Services with other services that you have in Azure, like Logic Apps or even Azure Functions. Okay, and one last thing that I want to tell you about is the Custom Vision service. And the Custom Vision service is important because it kind of complements the computer vision service that we took a look just earlier today. And in the Custom Vision service, we saw that we actually feed some pictures, and then the AI or the service itself provides us with some information about that certain picture. Now, if we provide some general purpose pictures like I did with some landscapes or people, things might go well. But if you want to do some really important things for your business, like for instance, in a factory, having a camera looking at all products that pass on a specific production line and identify faulty products. Of course, that this computer vision API will not be able to define or to know one way or the other which product is faulty and which product is not faulty. So here is where this custom vision API comes in, that also provides you with a web-based interface, but if you want to do this programmatically, you can do that by your own. And the main idea of this service is that you provide your data. So you provide a lot of images about your products, for instance, and you provide labels, or you create labels for each picture. So for the first picture, you see that this product is not faulty. For the second one, you put the label that is not faulty. For the third one, you put the label that it is faulty. And after you have uploaded some pictures and have created those labels for those pictures, you can simply train that model to understand which products are faulty or not. And from that point, whenever you want to check a new picture, maybe from a new product from the production line, you make a call to this custom vision service, and it would be able to respond you with or based on the training that you have created for that model. So if the product is faulty, it will return you that it is faulty. If it is not faulty, it will return you that the product is not faulty. Of course, it will return you this information with a certain confidence level. So in your application or in your specific business scenario or use case, you would also have to decide based on the confidence level, maybe if you really want to consider that product is faulty or not, or maybe if it is neutral, maybe considering putting those products I would say also for manual revision or similar things, but other ways for the products where it returns you a very high confidence level, then of course you can maybe just trust the model that you have trained and then mark or consider those products as being correct and not faulty. And just to end this session in a more funny way, and also based on this idea of training a model, this custom vision service, if you just want to get fancy and play around and just want to confuse your model, your AI, you could feed to it something like that. So if you do that, well, probably even the AI won't understand anymore if it's a dog, a muffin, several dogs, several muffins, and things like that. So yeah, if you want to know how to confuse AI, here's a very, very simple way to do that. And this being said, thank you very much for watching this session. I hope you learned some new things here. The main thing that I want to emphasize once again, if you have use cases where artificial intelligence could be useful, don't forget that we have in Azure this Azure Cognitive Services, which is a bunch of different services that are based on different machine learning algorithms, and you can simply bring intelligence to your applications just by calling some REST APIs, and that's it. This being said, once again, thank you very much for watching, and I hope to get in touch with you very, very soon. Have a nice day. Bye.